So, awesome. This is lesson 3-4, factoring difference of squares. There's these, we're going to put the conditions that you have to have in order to do this special pattern. So the first condition is that the degree must be even. So the degree must be even. So the degree should be 2, 4, 6, etc. Because that's what even means. Okay, the degree has to be even. The number of terms has to be 2, just like this. See how there's 2 terms right here? This is the general form that you want it in. So there has to be 2 terms. Number of terms must be 2. That is a must to use this pattern. When you use the pattern, you'll factor really quickly. Do you know what the word is when you have 2 terms for something? For a polynomial with 2 terms is a binomial. Awesome. So it has to be a binomial. And then you have to be able to take the square root of each term. So each term must be a perfect square. That's why it's called difference of squares. Must be a perfect square. And there's one more, even though there's not a line for it. It has to be difference. So just be sure this is a subtraction. That's why it's called difference of squares. That's the name for it. It's the difference of 2 perfect squares. And if all those are true, then we get to factor it doing this pattern. So I'll describe it. I'm going to start with examples, and then I'll go back and tell you the steps. So I'm just going to move this up a little bit. So we're going to start with this example. The first thing you always have to do before you factor any problem ever that you have to remember, I will admit I even forget. The very first thing you should always do when you factor to make your life easy, and in fact, if you remember to do this, you might even be done factoring. What is it? Take out the okay, let's look here. What's in common? What can we take out of 81x squared and negative 36? What number divide? A 9, right? We could divide both of these by 9. So before you start any problem, it's so easy to forget. You should take the 9 out, meaning write it in front of the parentheses, and then do the opposite of the distributive property. What times 9 gives you 81x squared? 9. And what times 9 gives you negative 36? Yes. So that is, no matter what pattern, no matter what you're doing, always, that will always be step number 1 in any factoring problem forever. Okay, now the rest of this is difference of squares, so I'm going to go straight to the answer. So you should, when you see difference of squares, you should be like, yes, that's difference of squares. So let's go through the conditions. What's the degree of this? What degree is this, the highest exponent? Yeah, so is it even? Yeah. Okay, so we got condition number 1, check. The degree is even. Condition number 2, the number of terms is 2. Is that true here? Do we have 2 terms? Yeah. Yep, so that's good. Each term must be a perfect square. Are these perfect squares? Yeah. Yep, and is it difference? Yeah. Okay, so here's how easy it is. What is the square root of 9x squared? 3x. So that goes as the first term in each set of parentheses. The first in both set of parentheses is the square root of that. What's the square root of 4? 2. And that is the second term. And the signs are always going to be, one is positive, the other is negative, and it doesn't even matter which order you do it in. So I'll just be consistent, and I'll just go like that. And do you see why that has to be? They have to be opposite signs. Yeah. Can someone tell me why? So that multiplies to, yeah. What, Tanner? Because a positive and a negative will cancel when you add it. So the inner and the outer add to 0. Watch. 6x minus 6x is 0, and that's why there's no term in the middle. If I were to FOIL this out, now I'm gonna FOIL this out just to convince you that this works. You don't need to write this, but I'm gonna FOIL it out. 3x times 3x is 9x squared. 3x times negative 2, negative 6x. 2 times 6x, positive 6x. See, those add to 0, and then 2 times negative 2, negative 4. So you see how you're left with 9x squared minus 4? And that's what we started with, the two terms we started with. And of course, the 9 out front is still there. So our final answer, maybe you want to box it, is this. Now, can we solve for x? So I saw a couple people last class solving for x. Is there a solution? Like x equals 2 or x equals... Why does that not make sense to solve it? Yeah, you're just multiplying two things together. It's not an equation. It's an expression. It's like saying 12 is the same as 6 times 2. Are you solving anything? You're just rewriting 12 as 6 times 2. That's what factoring is. You're breaking it down into a product. So there's no answer. There's no x equals something. You don't have to do the zero product property. It does not make sense here. Okay, let's do another one, difference of squares. We'll do 2 more examples. Try, what's that? Uh, 9m squared minus 64. Let's factor. What do we always do first? Yeah, take out the GCF. Is there anything in common of 9 and 64 that we could take out? Well, you might say 9, but try dividing that into 64, and it's not going to go evenly. You can't have decimals here, by the way. That means you can't factor it, and that won't happen today. Everything is factorable today. So there's no GCF. Okay, let's go to the answer. Watch how easy it is. So what's the square root of 9m squared? So that's the first term. What's the square root of make this a little bit bigger here. Square root of 64 is 8. So those are definitely the second terms. And then where do you want to put your plus and minus? I'll just go this way. It doesn't matter as long as they're opposites. That's the answer. That's factored. One last example, then we'll actually write out the steps and we'll be done for the day. This one is a little bit more involved, but you can handle it. It's difference of squares because there's 2 terms that are subtracted, the degree is even, and these are perfect squares. So we go for it. We go right straight to the answer. What's the square root of b to the 4th? b squared, so that's our first terms. What's the square root of 16? So those are our second terms. And where do you want to put your plus and your minus? Doesn't matter. But, does anyone see where we can keep going? Do you see difference of squares again? Yeah. Is it that one? No. Is it that one? Yes. So this we can't do anything else with. That's done. So let's copy that down. But that's difference of squares again, right? Those are 2 perfect squares subtracted. So we factor that again, and then we'll be done. So square root of b is? B squared is b yet? Square root of 4 is? 2. So 2, and put your minus and plus however you want. That is completely factored. So we're going to go write the steps for successful factoring, and then we are finished here. So steps for successful factoring. Number 1, take the square root of the first term. Take the square root of first term. So you can write the words square root, or you can write a radical. Take the square root of the first term. This goes first in both sets of parentheses. This goes first in both sets of, I'll just write parentheses. Then take the square root of the second term, of the last term, or second term, there's only two. This goes last in both sets of parentheses. And then you simply make one of them addition and one of them subtraction. And you are good to go.